Spars are the principal structural members of the wing. They correspond to the longerons of the fuselage. They run parallel to the lateral axis of the aircraft, from the fuselage toward the tip of the wing, and are usually attached to the fuselage by wing fittings, plane beams, or a truss. Spars may be made of metal, wood, or composite materials depending on the design criteria of a specific aircraft. Most wing spars are basically rectangular in shape with the long dimension of the cross-section oriented up and down in the wing. Currently, most manufactured aircraft have wing spars made of solid, extruded aluminum or aluminum extrusions riveted together to form the spar. The increased use of composites and the combining of materials should make airmen vigilant for wing spars made from a variety of materials. A spar may be constructed completely from composite material. In an I-beam spar, the top and bottom of the I-beam are called the caps, and the vertical section is called the web. The entire spar can be extruded from one piece of metal, but often it is built up from multiple extrusions or formed angles. The web forms the principal depth portion of the spar, and the cap strips, extrusions, formed angles, or milled sections, are attached to it. Together, these members carry the loads caused by wing bending, with the caps providing a foundation for attaching the skin. It could be built up from lightweight materials with vertical stiffeners employed for strength. It could also have no stiffeners, but might contain flanged holes for reducing weight but maintaining strength. Some metal and composite wing spars retain the I-beam concept but use a sine wave web. Additionally, fail-safe spar web design exists. Fail-safe means that should one member of a complex structure fail, some other part of the structure assumes the load of the failed member and permits continued operation. The spar is made in two sections. The top section consists of a cap riveted to the upper web plate. The lower section is a single extrusion consisting of the lower cap and web plate. These two sections are spliced together to form the spar. If either section of this type of spar breaks, the other section can still carry the load. This is the fail-safe feature. As a rule, a wing has two spars. One spar is usually located near the front of the wing, and the other about 2/3 of the distance toward the wing's trailing edge. Regardless of type, the spar is the most important part of the wing. When other structural members of the wing are placed under load, most of the resulting stress is passed on to the wing spar. False spars are commonly used in wing design. They are longitudinal members like spars, but do not extend the entire span-wise length of the wing. Often, they are used as hinge attach points for control surfaces, such as an aileron spar.